In this recording, I'm going to go over two application problems that are from the AP Calc Bible. The first one is from page 10, example 5. And for this one, a person 6 feet tall walks directly away from a streetlight that's 13 feet above the ground. So we know a couple things. We know the height of the person and the height of the flagpole, or the streetlight. The person is walking away from the light. So this person started at the light and is walking, they just drew him at this point now. But if they let that be x, they already gave us those variables, which makes it a little bit easier, then the rate of change of x is dx dt, and that's 2 feet per second. They want us to find out what rate is the length of the shadow changing. Well, y is the shadow. So the rate that the length of the shadow is changing would be dy dt. So we're finding dy dt. We're going to use similar right triangles to set this up. Proportion you could set up a number of ways. One way is 6 is to y as 13 is to x plus y. You could have also set it up 13 is to 6 as x plus y is to y. We would get the same thing once we cross multiply. And then we can get 7y equals 6x. Once we take the derivative of that, 7 dy dt equals 6 dx dt, we can solve for dy dt, plug in the 2 for the dx dt, and get our answer of 12/7 feet per second. Now part B says at what rate in feet per second is the tip of the shadow? Well, if the shadow's out here, this is the tip of the shadow, so we want to find out the rate of change of it. And we would get it by taking the derivative of x plus y. So the derivative of x plus y is dx dt plus dy dt. They gave us the dx dt. We just found the dy dt in the previous part of the problem, and we'll get the answer of 26/7 feet per second. Okay, the second question I'm going to do is another application. This one's on page 13. Oops, and this was example 1. Okay, so I think this is page 13, example 1. Nope, that's 14. Here's 13. Okay, so this one says an open box of maximum volume is to be made from a square piece of a material. So immediately we're starting with a square. It's 18 inches on each side. And what's going to happen is if you cut the corners, a little square out of each corner, and flip up those flaps, it's going to make an open box. So they want us to find out what that dimension x should be so that there's a maximum volume. So the volume of a rectangular solid or a box is length times width times height. So I know the height's going to be x when that flap is flipped. And then this length would be the 18 minus 2 of those x's. And then the other length would be another 18 minus those 2 x's. So what I did is, because I knew that those numbers were going to get large, but there was a GCF in both of these two quantities, so I factored out a 2 and another 2, so I factored out a 4. I left the x there, and now I have 9 minus x times 9 minus x, which is a little bit smaller. And then I'm going to distribute that x through the 9 minus x times 9 minus x. I'm going to keep that 4 still out in front so that when I take the derivative, I just have to take the derivative of this part, since the derivative will still be the constant times that 81 minus 36x plus 3x squared. And then I factored out the GCF of 3 out of that quantity, so 4 times 3 gives me the 12. And then I'm able to factor this a little bit easier. X equal 9 does not make any sense. If that square length were 9 here and 9 here, it would be 18, which is the entire length of this side, which wouldn't make sense. So we'll keep the 3. So 3 inch by 3 inch squares are what should be cut off. And then the maximum volume, if I put that x of 3 back in, I can find out it's 430